this is the function that we're interested in. Now, there are some questions there, but I'm actually going to ask you to just look at the function. That's all I wanted you to do, to read the question so you've got it there. And then I'm just going to pose the question to you, graph. That's all really, like the different parts of the way they're leading you through, that's all they really want out of this. Okay. Now, this is a fairly sort of standard way of, there's no integration involved or anything like that. We just need to differentiate, but it's still quite tricky. So I want you to think for a second. Take a minute. You can turn to the person next to you if you like. If that's all you had, and all I asked you to do was graph, where would you go with this? Where would you go with this? As it turns out, the question gives you a lot more hints, and it sort of pushes you in a very particular direction. But I want you guys to work a little harder. You know a lot about how to work with graphs like this now, right? You know about different kinds of, actually, I don't want to spoil it too much, okay? So I want you to turn to the person next to you, think about what can we know about this that will help us get towards a picture. Can you do that for a minute? Have a think.
Both sides.
Yeah.
How do you put that?
But then if we turn that, it'll be like tan alpha.
The answer is no. And this actually you gain.
And then you
I don't know why I forgot to write down.
That was a big discussion.
I'm really bad at this. Like, I always think that I don't know what's
Did you write that down? Okay, that was a minute. I'd like some suggestions, not actual things that you might have started doing, but what are some suggestions for directions we could start to head in that will yield some interesting or useful information to help us graph this? Any suggestions? Yeah.
literally apply the formula.
As in plots and values?
Yeah.
Okay, so I could plot points.
No, I mean like,
sorry. Yeah.
literally do it. Like, you know that the derivative... What?
Literally do what?
Because like,
Just
literally do
it. Just do it. Just start graphing something. So I don't entirely understand.
Wait, isn't the derivative of tan inverse x like 1?
So what you mean is differentiate? Is that
yeah.
what you mean? Okay.
Because that's what it's asking you to do, right? No, it's asking you to graph. It's asking you to graph. Because I thought the question was differentiate. I was like, why is this hard?
Okay, let's rewind a little bit. So the question is graph.
Okay.
So something that could help us here is differentiate. Okay, because clearly
Just literally just do
it. What's wrong with all you people? I just know what that looks like, right? Another suggestion, right?
You can take a look at the domains of both graphs.
Yeah, fantastic. Yep, good. So we know that there are going to be, for all the inverse trig functions, you've got to be careful with domain. Interestingly, tan inverse x, is just have a think about that guy. Where does he exist in terms of domain? He's okay, he exists everywhere, right? All revised x. However, this guy over here does not, right? And in order to have this guy, you need all of the pieces, right? Like if part of it's broken, then the whole thing is broken, okay? So just domain is the point we wanted. Okay, is there anything else that would be useful? Yeah, it's even and odd. Even and odd. So I'm looking for, does this function have any kind of symmetry that I can take advantage of? You guys know, most functions, if you just think about the whole world of universal functions out there, most functions do not have symmetry because it's a very, very special property. But the questions you're going to get in exam papers are kind of very skewed towards having features like this because this is a feature we want you to recognize. And so we assess it, right? 1, 2, 3, can I get some more suggestions?
Try and use it
Try and use double. So you're talking about identities. Where do you mean? I'm not entirely clear.
if you tan inverse.
Oh, I see what you mean. Yep, okay. So I'll write this down first. Identities. Question mark. Now, the only reason I'm going to put a question mark here is, just for the sake of this question, because I know exactly what this question looks like, I happen to know that in this case, we could go down this alleyway. It doesn't happen in this particular case to yield us much insight. However, there's no reason why it can't. You can see what he's getting at. Tan inverse of this and tan inverse of this. You don't have to only think of it this way, but these are kind of like angles, right? Like say if I gave to you, bless you, if I gave you tan inverse of 1, That's an angle. What angle is it? It's pi over 4. Okay? So tan inverse, sine inverse, cos inverse, whenever you see those, you should think, oh, these are kind of like angles, right? Now, therefore, if I've got an angle here and an angle here, one of the things I could do, and in another question, it might be more useful, is I could take, say, tan of both sides. Right? I could take tan of both sides. Because then you've got tan of A plus B. What is tan of A plus B? What's tan of A? It's tan A plus tan B on 1 minus. Okay, now just in this case, and we'll see, I'll show you why it doesn't end up going anywhere useful in this particular case. What would tan, I'm going to call this one A, and I'm going to call this one B. What's tan A? It's just going to be X. What's tan B? It's 1 on X. Okay, on my denominator I have, you see where I'm going, 1 minus tan A, tan B. Tan A, tan B. Uh-oh. So you see in this case it happens to not be very useful. But in other cases it is. And then what you'll get is just, you can consider it as an inverse function. Okay, like you'll have a tan of something over here, and you'll have something else over here you can work with. Okay? But it's not a bad idea, yes?
So if you've given up all life, you can plot a table of values.
You could, if you really have nothing else you can do.
Don't judge, okay?
You can plot points. And in fact, I am going to take advantage of that in a second. I am going to legitimately put that there. Okay, 5 points there. We're going to use 4 of them, except for the one that I just mentioned. So let's start to have a look through this. Do you think that's the most natural order to go in for this particular function? What do you think is easiest? Yeah, I think domain first is probably the way to go. I'd probably go to symmetry after that.
And then differentiate.
Then I'm going to differentiate. That tells me something about the gradient. You actually don't know, because again I know what this function is going to look like. Usually differentiating, there's an obvious thing missing from this list actually that's kind of under here,
Intercept?
which is intercepts,
I
right?
said that, no one heard me.
Sorry, my bad. It was lost in the cacophony of noise. Thank you. Intercepts, of course, are a particular value of, like plotting points, x equals 0, y equals 0. So usually we would like get this out and then see if the intercepts are even used to us, okay? As it happens in this particular case, they're not. Well, let's see what happens, okay? So let's begin with domain. We already almost got halfway there. This guy is used for all real values of x. This one almost exists for all real values of x, except for x equals 0. So what I'm going to say is, I'm going to say x can be all real values except x equals 0. Okay? So x equals 0 is the only hole in my function. I can exist everywhere else. And that's it. That's all I need to say about domain. I'm going to have a discontinuity of some kind. Could be an asymptote or something like that. We'll find out in a minute. Symmetry. Okay. Is this going to be an even function?
No.
What would it mean to be an even function? What's the definition of an even function?
F
F of x is equal to very good. So this is the kind of thing we're expecting, right? Which is why if you've got even powers, like if things are squared, that's why this kind of thing happens. Because everywhere you put in negative x all squared just becomes x squared, right? But when you have a look at this, yeah, I don't really see anything that matches even symmetry, right? However, what is f of negative x in this case? It's going to be like just going for a straight substitution, right? It's going to be tan inverse of negative x plus tan inverse of negative 1 on x. Now the lovely thing about this, the reason why symmetry is a great direction to go in, is because we know that the component bits, tan inverse and tan inverse of whatever, they're odd functions, right? They're odd functions. So therefore, tan inverse of negative x is negative tan inverse of x. And the same thing happens here. Do you notice that? Minus tan inverse of 1 on x. So I've got a double negative, which corresponds to my double positive here. So this is negative f of x. 1. So you can see, if all your pieces are odd, right? If all your pieces are odd, then your total thing will be odd. Does that make sense? Cool. So I have some symmetry now. I know that there's this discontinuity. I know that I actually now only need to graph one half of this, right? And then when I want to get the other half, I'll just do a reflection, okay? Or a rotation, depending on the way you think about it.